Hi everyone. Today in this video we will discuss conversion from context big grammar to pushdown automata. Right? So far you learned my videos how to design a context big grammar, how to design a pushdown automata for given languages. Now let us understand today video how to conversion from context big grammar to pushdown automata. Before designing conversion, let us understand how theorems are work. Statement like this: if language is accepted by some context-free grammar, then it is also accepted by pushdown automata. Then it is also accepted by pushdown automata. Right? So there is another theorem is indicating here. So if language is accepted as some PDA, then it is also accepted by some context-free grammar. The overall corollary will be like this: a language is context-free grammar. If language is context-free grammar, if and only if it is also accepted by pushdown automata. That means if the given language is context-free, then it can also accepted by pushdown automata. That is, context grammar and PDAs have equivalent computation. That means both of them have a equal power, and you could also express this in a capability way. Right? Both are more powerful and more powerful computation. Right? So let us move to the next point is here. That means the context grammar and pushdown automata both are same. Both are same. Okay. Let us go to the next topic. Right. Let G be context. Let G be context be. Let G be generated by context free grammar, then L can be accepted by PDA by empty stack. As you all told in the earlier case, PDA can accept in two ways. One is by empty stack and other is by final state. Another way is final state. It accepted in both the cases. Either you can make the stack as an empty, or you can make that PDA as final state. Both it will be accepted. So it will be like this: the PDA can either accept it in empty stack or unaccepted by final state. That means any language is either can generated by accepted PDA by empty stack, or it can be accepted by final state. This is a scenario. You can understand how the PDA and context free grammars are both are equivalent. So before conversion, let us understand some of the steps you have to follow. The steps are like this. The first step is the first symbol on right hand side. Production must be a terminal symbol. The following steps are used to obtain PDA from CFG. Right. So first step is convert the given production of CFG into GNF. So you know already what is GNF. So any production should be in the GNF form. Then only is easier to convert it to PDA. Otherwise, it's not possible. Okay. So any given grammar should be in GNF. You have to use that as an input to convert as a PDA. Otherwise, you have to convert it into GNF first, then you can start converting into PDA. Step 2, let Q0 is a start state, is nothing but an initial symbol on stack. Without consuming any input, push start symbol is on stock. Then just change the state to Q1. That means you are in Q0, that is delta of, you are not consuming any input, and top of the stack is Z0. So then you have to change to the Q1 state. Then what is the start symbol? Yes, push onto the stack. Right. So that will be the second step. Okay. Second step. The third step, that is, I think you can understand now what I explain here. So this will be the transition function, okay, as per the step 2. The step 3 is for each production as given as A gives A alpha, A gives A alpha. That means any production is in the form of A gives alpha, that is the right hand side start with the terminal symbol followed by any non-terminal symbols. That means alpha should belong to V star. It is nothing but it should be in the GNF form. Right? The corresponding production will be like this. Delta of Q1, that is the right hand side terminal symbol A. That production is A. You will be in the same state and push whatever symbol on alpha. Alpha has given some symbol, non-terminal symbol, you push onto the stack. Okay. Let us move to the other step. Finally, in state Q1, without consuming any input, just change the state to QF and make that as an accepting state. The transition will be like this. Delta of Q1, you are not consuming any input, and top of the stack is Z0. You are just changed to QF and retaining Z0. This will be the transition, right? So I will overcap once again. I will be recapping all these steps. So given production, you should be in the GNF form, and the first step 2 is the before taking any input, consuming any input, just start symbol pushing onto the stack. This will be the second step. And the remaining step 3, any production is in the form of like this, just follow the corresponding transition like this, right? Then after all this production, it will follow this condition step 3. Then finally, so all the production are over, then at the end you have to, without consuming any input, and retain the top of the stack is Z0 and reach to the QF. Okay, so once you understand this, so we will be just the steps I have given. Let us see this. You have to apply these all rules in while conversion from CFG to PDA. The first problem will be like this. Convert the following grammar to PDA that accept the same language. Right. Look at this given grammar is already in GNF form. Right. What is GNF? You know already. A gives A alpha. Any production it should be in this form. What is that right hand side? It should be start with small a and followed by alpha. Alpha is belong to V star. Right. So that means it is alpha is always have a sequence of non-terminal symbols. Right. So then it's not a problem. We can skip step 1. Straight away we can start to step 2. So what is step 2? Without consuming any input, just push start symbol onto the stack. Right. So that is the step 2. That means delta of Q0 comma, we are not consuming any input, and top of the stack is Z0, right? Top of the stack is Z0. Then which is equal to changing state from Q0 to Q1. I'm pushing S onto the stock, that is SZ. Is not. The first step is over. Step 3. Look at all other productions, all other production. Here it is. There is the S as given here. So S, the S production S gives A, B, C. Right? I will follow the step 3. Any production is in the form of A gives A alpha. Right? A gives A alpha. That means it is like this. Any production is in the form of A alpha. Then correspondingly you write A Q1, then A, and that production, right, which is equal to delta Q1 comma alpha. Q1 comma alpha. You have to write it like this. Let us understand this. Which is the production will be in this form. That first production S gives A, B, C. In this case, A is A, alpha is A, B, C. Then what is the production is here? The delta of, look at this, delta of Q1 comma A, Q1 comma A, and this will be the Q1 comma A, and this will be the S, which is equal to Q1 comma ABC. This is alpha. Alpha is ABC. A is A. And similarly for this production, second production, A gives AB. There are two rules are there. You take first rule. A gives AB. So this also will be similar to the A gives A alpha. In this, they will be in the same state Q1, and which is there in this in place of A small a only, small a only, which is the production as producing here capital A, that is equal to Q1 comma, which is the alpha place, which symbol is there in the alpha place, B, right, like this. We have one more production, that is A gives A. A gives A gives small a. Right, here it is alpha is absent. What is alpha in place of alpha? Epsilon. You can put or epsilon, right? So that means how to write it here? Delta of Q1 comma, what is there in the A? That is A will be there, right? There is a A. Okay. Then which is equal to Q1 comma epsilon. Why epsilon has come? Because of nothing is there in place of alpha. Nothing is there in place of alpha. Right. Similarly, you can also write B gives BA or B. How to write this? Right. Delta of Q1 comma small b, B, because it is a B is producing BA, and in place of alpha has written A. Q1 will be remain same. In Q1 only you are pushing all this element to the top of the stack. There is one more rule is on B. B gives small b. This is also similar to this. How do you write? Delta of Q1 comma small b, B, which is equal to Q1 comma epsilon. Nothing is there in the place of epsilon. Right? In place of A, B will be there. Right? There is one more production, SC gives A. This is also similar to the B gives B, A gives small a. Right? How do you write that? Delta of Q1 comma A and C is equal to Q1 comma epsilon. Right? So we follow the step 1, step 2 and step 3. Right? What is the step 4? Step 4 is all this production is over. Finally, we need to make without consuming any input. Just go to the final state and stop the process. Look at that. Right? So there is Q1 without consuming any input. Z0, go to the QF and Z0. So this is the only 4 step you have to follow. Write the transition for all this grammar. So we are convert the entire grammar to PDA. Entire grammar to PDA. Right. Now what is the remaining part is you have to define M. What is M? M is nothing but PDA. It is describes 7 tuples. 7 tuples. What are those 7 tuples? 7 tuples. What are those 7 tuples? Are, look at this. That define PDA. These are the 7 tuples. These are the 7 tuples. One is Q, sigma, delta, tau, Q naught, Z naught, F. Then what are these symbols? You might have seen all these symbol in many of the earlier finite automata and pushdown automata definition. Right? In this transition, what is Q? What is Q is here? Q is what are the state you are use it in your transition while converting from grammar to PDA. Q naught, Q1 and QF. Q naught, Q1, QF. What is the input alphabet in this grammar? Small a, small b. Right? Small a, small b. Small a, small b. Then what is a delta? Delta is a transition function. This is what already written transition function in this. So all these are called delta transition function. What is toe alphabet? It is stock alphabet. Stock alphabet is a stock alphabet. What are the stock alphabet? Including sigma alphabet, small a and b. And what are the stock production non-variables? S, A, B and C. Okay. So S, A, B, C, small a and small b. What is Q naught here? Q naught is an initial state. What is Z naught? Z naught is a initial stock symbol. What is F here? You are using accepting state QF. So if you write like this, you will get the full marks. Need not to write a transition diagram for PDA. Just write the transition function, all the transition if we write like this. So you will get the full marks. So hope you understand this concept. Let us see one more example on this. Right. So convert the following grammar to PDA that accept the same language. Look at this grammar. This grammar is already in JNF. I will not show any of this, just I will explain it. There is a production is like this: A, B, B. Right? So what is the step 1? Step 1 is without consuming any input, just push S onto the stock. Then how do you write? Delta Q naught epsilon Z naught, which is equal to Q1, you change the state and pushing S onto the stock, since it is as per the procedure. Right. Then this production you can take the step 2. Step 2 is this. Step 1 is already is in JNF form. So you need not to apply it to conversion from JNF to JNF form. So you can directly take the step 2. Step 2 will be pushing S start symbol onto the stock. Step 2, this grammar is already in the form of A gives C alpha. If that is a case, what will be the corresponding transition? Q1, because you are already in Q1. What is the A here? A is a small a. Then what is in place of which is the production? S is a production, which is equal to Q1. In place of alpha, what will be there? A, B, B. Right? Then third product, another production is on S. S gives A. Right? So delta of Q1, in place of A, small a, it is A only. In place of capital A, what will be there? That is S only. S has 2 production, Q1. And what is alpha? A. Then what is the Third rule, that is fourth rule. Rule will be like this. By the time all the productions are over, then it is all the symbol are pushing onto the on top of the stack. Then there is no more input, just you are in the state 1. There is no more input, on top of the stack is Z0. Just you have to change to QF, then go to the, will be retained the top of the stack is Z0. These are the transition function of PDA. So then finally what you want to, you have to define PDA. Define PDA means you have to define M. Let us see them. Okay, one after the other one. Look at this. Solution will be like this, as I explained in writing. Right now we can see that how that will become. So all this, right, define PDA. It is Q0 Q1 QF, Q0 Q1 QF. Then delta is sigma is small a only. Then delta is all this transition function. Tau is SAB and A stock alphabet. Q0 is Q0 and Z0 is initial stock. Finally QF. Like that you can convert any grammar to PDA very easily, right? Hope you understand this problem. Let us see some more problem in the next. Right? Obtain a PDA to accept a language. Obtain the PDA to accept the language A power n and B power n such that n is greater than or equal to 1 by writing a CFG. So grammar will be like this. S gives A, S, B or AB. So this will be generating this kind of language A power n and B power n such that n is greater than or equal to 1. That means n is equal to 1, one of the string is generated like this AB. This, if you have AB has come, you have to use the recursive function S gives A, S, B. But first of all, as per our rule, which is in the form of GNF, no. Because on right hand side, though it is started with the small terminal symbol, but it is the alpha will not be like this, because alpha should be only non-terminal symbol. It is not in that format, right? So then it is not in the GNF form. It's not in the GNF form. You have to convert this into GNF form. How do you convert this? You know already how to convert the GNF into. Have explained in my previous video. You can go and check that how to convert the given grammar into GNF. So S gives A, S, B. In this case, I'll convert this. First, S gives A, S, B or A, B. What is B here? B gives B. Right? This grammar converted into GNF. Then in place of B, I will introduce one variable symbol. So we have replaced these two. Then by capital B, you will get this in the GNF form. This will be in the GNF form. Right? So now, this will be in the GNF form. So now you can easily after convert this into. Right? Let us understand now. Will we go like this? As you told that A gives A alpha and alpha is this. I convert just before it. So it is in the form of GNF. Now it is easy for you to follow the step 2. What is a step 2? You have to, without consuming any input, just push a start symbol onto the stack. Just push it to on top of the stack. What is the next one? So you take the first rule. S gives A, S, B, A, S and SP is pushing onto the stack. What is the second rule of S? S gives AB. You take that. So that is also over. What is the next one? This one is the B gives B. That is B and B, which is equal to Q and epsilon. Right? Alpha is an epsilon. So now all these are over. Just you have to follow the last step. Last step is the input is over and top of the stack is Z0. Just change the state to Q1 to QF and retain the top of the stack. Now it is a time for writing the PDA. Writing a PDA means you have to define the 7 tuples. 7 tuples is, what is the capital Q? Capital Q is Q0, Q1, QF. What is the input is AB. Okay, it is here input symbol AB, and transition function this itself already written, that is a delta. Then tau is SB and AB, it is stack alphabet. Then Q0 is the initial state, then this will be the stack symbol Z0, then it is a final state S. So I think you hope you understand this concept very well. Let us understand some more problems in the next video on another way of constructing PDA from context B grammar. This PDA conversion from PDA context B grammar to PDA by accepting a final state. As you told, PDA is accepted in two ways. One is by final state, one is by accepting by empty stack. This method is, the given grammar should be in the GNF form, then you can easily convert this into PDA by accepting the final state, right? In another way you can do it. In the next video I'll explain it very detailedly. Okay, so